Greetings and hello everyone. Today we're going to be working with distance. So let's go ahead and start off with a key concept. So if I have a number line, and on this number line I have point P and I have point Q. I'm going to call point P x1. I'm going to call point Q x2. So if P has coordinate x1 and Q has coordinate x2, then PQ equals the absolute value of x2 minus x1, or the absolute value of x1 minus x2. So we're going to use this formula to find the distance of the required points. So let's go ahead and try out an example. So let's take a look at example 1. It says use the number line, find the distance of CF. So let's find our points. So C would be -1, and I'm going to call this my x1. F would be at 5. I'm going to call this my x2. So I'm going to do both directions just to show you that it works. So let's try the first direction. So CF equals the absolute value of x2 minus x1. Well, x2 is 5. So this is going to be the absolute value of 5. x1 is -1 minus -1. When I have a minus minus, that is really a plus. So this is going to give me the absolute value of 5 plus 1. 5 plus 1 is 6. And the distance 6 is from 0 is 6 spaces. So the distance of 6 is, or the distance of CF is 6. Now let's go the other route, or the absolute value of x1 minus x2, just to show you that it works. So as we said, x1 is -1 minus 5. When I have two negatives like this, I add the numbers together and keep the sign. So it's going to be -1 plus 5 is 6. -6 is 6 spaces away from 0, so our answer is going to be CF equals 6. And we got the same distance, because these are just different ways of looking at the same idea. Let's take a look at example 2 now. So in example 2, it says determine whether CB and DF are congruent. So we want to see, is CB congruent to DF? So I'm going to use the distance formula twice. I'm going to use it first on the length of CB and second on the length of DF, and see if I get the same number out. So C is at -1. B is at -3. So CB equals the absolute value of x2 minus x1. So this is going to be my x1. This is going to be my x2. So I have the length CB equals -3 minus -1. Double negative here turns into a positive, so I get CB equals the absolute value of -3 plus 1. -3 plus 1 is -2. So the absolute value of -2. And negative 2 is 2 spaces away from 0. So the length of CB is going to be 2. Now let's see what DF gives us. So D is at 2. D is at 2. F is at 5. So the length DF, to find the distance, I'm going to do the absolute value of x2 minus x1. Plug in my numbers. This is going to be my x1. This is going to be my x2. 5 minus 2. 5 minus 2 is 3. And 3 is 3 spaces away from 0. So the length of DF is 3. Well, 2 is not equal to 3, so not congruent. And that's all we have to do for example 2, is just show that they're not congruent by showing what the length of the one segment is and what the length of the other segment is. So that's how you deal with distance on a number line, one-dimensional. What happens if we have two-dimensionals? Well, that's going to be our next idea, distance formula on a coordinate plane. So I'm going to use the same points, P and Q. So if P has coordinates x1, y1, and Q has coordinates x2, y2, then the distance of PQ is going to equal the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to use the square root in order to find what the distance is. So let's give this a try with an example. So we're taking a look at example 3. So you have J and K. So this is going to be my x1. This is going to be my y1. This is going to be my x2. This is going to be my y2. So I'm going to start off with writing the formula. The distance of JK equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now I'm going to fill in the values. So I have all the values up here. I'm going to substitute them in down here. So the distance of JK equals the square root of x2 is negative 3, x1 is 4, minus 4 squared, plus y2 is negative 7, y1 is 3, 7 minus 3 squared. You'll notice that the squares are known as superscripts. So they're not multiplying this by 2, they're taking whatever's in here and multiplying it by itself. So we'll see that on the next line. JK equals the square root of negative 3 minus 4 more gives me negative 7 squared, plus negative 7 minus 3 more gives me negative 10 squared. So now we'll apply this. So negative 7 squared means negative 7 times negative 7. That's what negative 7 squared equals to. So that's going to give me positive 49. And negative 10 squared equals negative 10 times negative 10. Well, negative 10 times negative 10 is 100. Add these two together. So we get JK equals 149. And if I type that into my calculator, I'll get out about 12.2. So if I multiply 12.2 times 12.2, I get roughly 149. It's not going to be exact. That's why I have the approximation right there. Let's take a look at our last example. So we have two people going up a mountain when they spot each other. So our first is at the coordinates 212 and 151.6. Our second person is at the coordinates 435.3 and 311.3. So this is going to be my x1, y1, x2, y2. So I want to find the distance between these two people. So x2 minus x1 squared plus y2 minus y1 squared. So I start off with writing the formula. Now I'm going to plug in the values that I have. So I have all the values. I'm going to plug them in so I can find what the distance is right here. So this is going to give me the square root of 435.3 minus 212 squared plus 311.3 minus 151.6 squared. Do the subtraction. When we do the subtraction, we get 223.3 squared plus 159.7 squared. Now I'm going to multiply 223.3 by 223.3. When I do that, I end up getting 49,862.89 plus 25,504 and 9/100. Add these two together. When you add them together, you get 75,366 and 98/100. But this is kind of hard to picture. So let's take the square root of it. And when we take the square root of it, we get approximately 274 and 5/10 feet. So the distance these two people are from each other is 274 and 5/10 feet. So this is how we work with distance using a number line and how we work with distance using a coordinate plane. Have a great day.